Hey students, this is Mr. Woodward, introducing some key concepts about motion in this video. So things like position, displacement, velocity, and acceleration, terms that we will be using a lot in this unit on kinematics and the way that things move. So we're going to be learning to differentiate not just the value of something like the value of an object's position or its displacement or its speed, but also its direction. And this is going to be a key idea in this video. So taking a look here, typically when we measure something, we do not include the direction of our measurement. For example, when measuring out the length of your bedroom wall, you might say 10 feet, or when measuring the speed of a car, you might say 70 miles an hour. But in physics, especially when talking about motion, we often use measurements that deliberately include direction, and these are called vector quantities. You might have heard of a vector before. For example, instead of measuring the bedroom wall's length at 10 feet, you could use the vector quantity of position and specify that the wall extends 10 feet to the right, or that the position of the corner of the wall is 10 feet to the right. And instead of measuring the car's speed at 70 miles per hour, you could use the vector quantity of velocity and say 70 miles per hour to the north. So the addition of the direction takes it from something that is just has a value, like 10 feet or 70 miles per hour, and it includes direction, makes it a vector. The most common vectors that you will need to understand when discussing the physics of motion are position, velocity, displacement, and acceleration. These terms might sound familiar, but they are more nuanced than students often realize. And so again, the big idea here is the idea of a vector. It's a quantity that includes both magnitude, which is a fancy way of saying how much or the value of something, and then the direction, where it's headed. So our first vector is going to be the position vector. And the definition of position is the location of an object in space. And of course, we are including direction. When we talk about position in an equation, we're going to use a variable to represent position. The most common variables are the variable x for a horizontal position, or the variable y for a vertical position. For example, a position vector might be something like 14 meters north. Or a position vector might be like -6 feet. The negative means that the position of the object is in the negative direction. Or we could include a position vector like 87 degrees west of north. If you have a positive position value, it means that the object is located in the positive region. Similarly, if you have a negative position vector, it means that the object is located in the negative region. Let's take a look at an example of how we can talk about or identify position vectors. So I'm going to skip ahead to a diagram here in example 1. So it says, a car with a leaky engine travels down a street and drips oil beneath it every second. As a result, a record of the car's position is left on the road as a collection of dots. And so you can see them here. This is the position of the car every time it drops oil. The car moves leftward from a positive position as shown below. So I've identified here that the starting time is at this dot, and the car is going to move this way. Use the diagram below to identify a bunch of different things, okay? So let's try this together. Question A, it says, what is the car's initial position? The word initial means starting. Well, its starting position is going to be here. And before I get too far ahead of myself, it's usually really helpful in these problems to actually label the diagram with the position at each dot and the time. So if this says that the car drips oil beneath it every second, then we can say that this first dot is t equals 0, and I'm actually going to just write it a little bit closer. And then that the next dot would be 1 second later. So this would be t equals 1 second. And then the next dot is 1 second later, 2 seconds. This would be 3 seconds. This would be 4 seconds right here. So it's a 4-second journey. And then similarly, I'm going to label the position. So this here is the 0 meter mark. And it says that the, and actually I should include this because it doesn't say in the example directions. We will assume that every grid mark, like the distance from here to here, is 1 meter. I'm going to go ahead and add that. So if this first dot is 0 meters, then that means that this, if this dot here is 0 meters, then that means that the dot at 3 seconds would be located at 1 meter, and that this 2-second dot would be at 1, 2, 3. This would be the 4 meter position. 5, 6, 7, 8. This is the 9 meter position. 10, 11, 12, 13, 14, 15. And this is the 16 meter position. So now I have the car's time and position for each dot. All right, so back to question A with the car's initial position. So I've already labeled where this position is. So that initial position is 16 meters. The position after 1 second is going to be here, 9 meters. The position after 4 seconds is going to be right here, 0 meters. And then the final position is another way of just describing its ending position. That's the same as its position after 4 seconds. So that's also 0 meters. So this is 4 questions about position. The position of an object is its location in space, where there is a positive and there is a negative region. Let's go back to the next vector called displacement. So the definition of displacement is any change in position. This means that the object has to be moving, right? Because its position can't change if it's standing still. In equation form, we use the variable delta x, a change in x, which, by the way, means the final x position minus the initial x position, right? This is the ending place minus the starting place. We also can use for a vertical displacement delta y. So if something is moving up and down, it will experience a vertical displacement. And so that would similarly be the final vertical position minus the initial vertical position. So delta x and delta y will show up in some equations. For example, the displacement of an object can be 14 meters north, which I know was the example that I used before, but this time it means that the object is moving 14 meters north, not necessarily that it's located 14 meters north, or that its displacement from one time to another was 14 meters in the north direction. Or an object could have moved -6 feet, meaning 6 feet in the negative direction, or 87 degrees west of north. So just by looking at it in the description, you can't necessarily tell if it's a displacement or a position. A positive displacement means that the object is moving in the positive direction. Notice that was similar to a position, where a positive value for position means it's located in the positive direction. A positive displacement means it's moving in the positive direction. Okay, a little bit different from each other. Similarly, a negative displacement means that the object is moving in the negative direction. So let's try some of these back at our example. Here we go, the car with the leaky engine that's dripping oil. Now in questions E and F, we have some displacement questions. So question E, it says, what is the car's displacement from 1 to 2 seconds? And I'm going to clear up this diagram a little bit, getting a little bit messy here. So the displacement from 1 to 2 seconds. Well, we're talking about from here to here, from 1 to 2 seconds. So that's its delta x, right? Which is the final position minus the initial position. So the final position is the 2-second position, that's 4 meters. The initial position is the 1-second position, that's 9 meters. And so we get negative 5 meters, which means that the car is moving to the left 5 meters, which you can see in that purple arrow that I drew, 5 spaces to the left. Letter F, what's the displacement from 3 to 4 seconds? So let's take a look at this. Now from 3 to 4 means that we're going from here to here, okay? So we can see the delta x now is 1 meter. Excuse me, we start with the final position. 0 meters minus 1 meter gives us negative 1 meter. Okay, it moved 1 meter to the left.